In previous modules in this series, we've looked at typical boiler construction, including combustion equipment for different types of fuel. So let's turn our attention now to boiler operation, and we'll begin by looking at a typical startup procedure. Of course, the precise actions and maneuvers that you take will vary from boiler to boiler, particularly with different types of firing. But the principles and operating requirements are the same. Let's assume that our boiler is being returned to service after a maintenance outage. It is completely cold. The first step in preparing this boiler for service is to make sure that all of the maintenance jobs have actually been completed and that all permits to work have been canceled. We then need to take a walk around the boiler to make sure that all workers are out, all tools, materials, and debris have been removed, and that access doors and manholes are closed. All auxiliary equipment, such as feed water pumps and fans, must also be ready for operation with switchgear and breakers racked in and power supply available. If the boiler has been drained during maintenance, it will now be necessary to refill to the working level. Before admitting any feed water into the boiler, make sure that the appropriate drain valves are closed. We must also check that the air vent valves are open on top of the steam drum. The superheater drain valves should also be open. In order to pump feed water into the boiler, it may be necessary to run the feed pump. However, in many installations, an auxiliary low-pressure pump may be provided for this purpose. As feed water enters the boiler and the water level rises in the tubes, air will be expelled from the open vents. The boiler should be filled to a level so that it is just visible in the bottom of the gauge glass. That is about 3 or 4 inches, say 10 centimeters below normal working level. The reason for this is to allow for expansion as heating of the water takes place. While the boiler is filling, we should make sure that the combustion equipment is primed and ready for service. Startup burners normally use light oil or gas, both of which are readily combustible. However, before lighting a fire in the boiler, it is essential to purge the furnace and gas passages. This action consists of passing a large quantity of air, say 40% of rated flow, right through the boiler and up the chimney to atmosphere. The objective of this is to purge, that is, sweep away any combustible gas that may be present, perhaps in pockets of the furnace, superheater, or air heater. If purging is not carried out, there is always the potential for an explosion to occur when the first burner is ignited. The purge action is carried on for several minutes, and this requires that the forced draft fans be run and induced draft fans if installed. After purging, the airflow is reduced to the pre-established startup value, usually 10 or 15% of rated flow. The boiler is now ready to begin firing. Each startup igniter is initiated either by local push button or remotely from the control room. The igniter runs through its own startup sequence as follows. Check that there is a flow of combustion air. Check that oil pressure is correct. Close the switch to ignite the spark plug. Check that the arc is present. Open the ignition fuel valve. Observe that ignition takes place and that the fuel continues to burn. Once the fire is established, the spark plug igniter will be switched off by a timer. If ignition does not occur within about 30 seconds, the fuel valve will be closed and the condition alarmed. The rate of adding heat to the boiler is dependent upon the number of startup guns which are placed in service. Also, in many cases, the fuel pressure to the startup guns can be adjusted so as to allow further control over heat input to the boiler. It takes a considerable amount of time to heat all the metal in a cold boiler, including the water contained inside the tubes and drum. We should expect to see steam blowing from the air vents after an hour or so. We will also notice that the level of water has risen. This is due to both thermal expansion and also some swell as boiling starts to take place. You will remember we discussed swell and shrink caused by steam bubbles in an earlier module. When the steam pressure rises to, say, 20 psig or 140 kilopascals, the air vents on the steam drum should be closed. At this point, we can assume that all air has been expelled from the boiler, and steam at this very low pressure fills the space above the water as well as inside the superheater as far as the boiler stop valve. The temperature of the water and the steam and the water wall tube metal will all be at or close to the saturation temperature